Hey everyone, welcome back. In this video, we'll go over a few examples on how to develop a precedence diagram for construction projects. First, let's review some common mistakes made by students and young engineers when developing a precedence network. One of the most common errors is a logic loop. You must avoid logic loops because they prevent you from calculating activity durations, and scheduling software will not accept them. To avoid logic loops, keep the logic as simple as possible. Here is an example of a network with logic loops. There are 3 loops in this network. The first one is between activities B and C. In this loop, C depends on B, and then B depends on C, making it impossible to determine which task should be executed first. The second loop is between B and A, and the third one is between A and D. So, what should you do if you find a loop in your network? A loop appears because of incorrect logic. If you discover one, you must carefully review the logic involved and identify the incorrect dependency that needs to be removed. Another common type of error is dangling activities. In this network, assuming node 10 is the finish milestone, nodes 7 and 8 are dangling because they have no successors. This could happen due to a missing dependency in the network, possibly because a user accidentally deleted the connections. To avoid a dangling network, make sure that every activity has an outgoing arrow on the right side, except for the finish milestone. Every activity has an incoming arrow on the left side, except for the start milestone. If your network follows these 2 rules, you can prevent dangling errors. Another very common error is the inclusion of redundant logic. Redundant logic occurs when the timing of a successor activity obviously does not depend on the timing of its predecessor. Here is an example of a network with 1 redundant logic, the connection from the finish of D to the finish of G. Why is this logic redundant? To go from the finish of D to the finish of G, you can follow this green path. The finish of G must come after the finish of F. The finish of F must come after the finish of D. Since the logic already ensures that G finishes after D, there is no need to define a direct connection from D to G. This makes it redundant and should be removed. Alright, now let's go through the first example of creating a precedence diagram. You've got a table listing the project's activities, their descriptions, and the immediate predecessors, IPA. Using this information, we're going to build the precedence network. Okay, let's review the given information. We've got activities labeled from A to H, their description, and IPAs. As you learned in the previous video, there are 4 types of logic relationships between activities. Finish to start to start, finish to finish, start to finish. To draw a precedence diagram, you need to know the type of relationship and any lag or lead time. Since this information is not clarified in this example, let's assume that all IPA relationships given in the last column are finish to start with no lag or lead time. Alright, let's get started. The first activity in the network must be the start milestone. To represent it, draw a rectangle box and write the activity name in the middle. Next, activity A, layout foundation has no predecessor, so it starts right after the start milestone. Since all relationships in the project are FS, the arrow must go from the end of the predecessor to the start of the successor. For activity B, dig foundation, it is preceded by activity A, so you draw it after A with an arrow connecting them. Next, activity C, place formwork is preceded by activity B, so you position it next to B and connect them with an arrow. Activity D, place concrete, is preceded by 2 activities, G and H. Since we haven't drawn G and H yet, so we need to skip it for now and come back to it later. Let's move forward with the next activities. Activity E, purchase, steel reinforcement, has no predecessor, so it starts immediately after the start milestone. Activity F, cut and bend steel reinforcement, is preceded by activity E, so we place it next to E and connect them. Activity G is preceded by 2 activities, C and F. To represent this, we draw G to the right of both C and F, then draw 2 separate arrows, one from C to G and another from F to G. Activity H, order concrete, has no predecessor, so it also starts right after the start milestone, just like E. Now, let's go back and complete what we skipped. Activity D, place concrete, is preceded by G and H, so now that both G and H are in the network, we can add D and connect G and H to it. As the last step, we need to add the finish milestone. To draw the finish milestone, we need to find the last activity in the network. Here, D is the final activity. Why? Because it has no successor. So the finish milestone must come right after D. We draw it and connect D to the finish milestone. Now the precedence diagram is complete. Let's move on to the second example, which is a bit more complex than the first one. Like the previous example, we have a list of activities, but this time, we're also given the specific types of relationships, as well as any lag or lead times. For example, activity G is preceded by activity E with a finish-to-finish relationship, while activity K comes after activity D, following a start-to-start relationship. Some of the relationships also include lag and lead times. For instance, activity H follows activity C with a 2-day lag, while activity M comes after F with a 1-day lead time. And just like in the first example, if the type of relationship isn't mentioned in the problem, you can assume it's a finish-to-start relationship by default. Let's begin by drawing a PDM network for this project. The first thing we need to do is draw the start milestone activity. Now, let's take a look at the table. As you can see, we have 4 activities that can start as soon as the project begins, including A, B, C, and D. Let's add these activities into the network. These 4 activities must be connected to the start milestone through finish to start relationships. Next, we have activity E, which is preceded by activity B. Since no relationship type is specified, we'll assume it's a finish to start relationship. Activity F is preceded by 2 activities, A and E, so it needs to be connected to both A and E like this. Next, activity G. This is preceded by E with a finish-to-finish relationship. Note that for a finish-to-finish relationship, the arrow must start from the right side of the predecessor to the right side of the successor. Activity H is preceded by C with a lag of 2 days. To show this, we connect C to H using the finish-to-start link, then add a plus 2-day lag to the link. Activity K has D as its predecessor through a start-to-start SS relationship. The start-to-start relationship between D and K is presented like this. We draw an arrow from the left side of D to the left side of K. Moving on to activity L, this is preceded by 3 activities, F, G, and H. So you need to connect the finish of all these 3 activities to the start of L. Next, activity M. This activity is preceded by F with a 1-day lead. To indicate the lead, we use a negative sign on the link. Finally, the finish milestone is reached once M, L, and K are completed. Now, we've depicted all the relationships specified in the table, but are we done? Not yet. There are 2 dangling errors in this network. To avoid these errors, you must check the following conditions. Number 1, every activity must have a tail, except the finish milestone. Number 2, every activity must have a head, except the start milestone. Let's go back to the network and find the dangling errors. The first one is at the start of G. This activity is missing a head arrow coming to the start of the activity. To fix this, we add a finish to start link from the finish of the start milestone to the start of G. There's another dangling error in the network. Can you spot it? It's activity D, which has no tail arrow at the end. This error can be fixed by adding a finish to start link from D to the finish milestone. Now, what happens if we don't fix this? If we do not add the link from D to the finish milestone, and if the duration of D is very long, the finish of D might occur after the project's finish milestone, which doesn't make sense since the finish milestone should only be reached once all activities are completed. Alright, this is the final precedence diagram for the given project. When doing your homework, make sure to check for all the dangling errors. That's the end of this video on PDM network examples. Goodbye, and see you in the next video.